All right, so last class we had spoken about how can we figure out how far things are away from the mean. And in particular, right, we were looking at the z-score as a tool for measuring the distance, like the exact distance in terms of the number of standard deviations from the mean. This time we want to use the median, right? The median as our frame of reference for measuring where things are relative to the median. So just as a little review, we have the interquartile range, we have box plots. So we should know how to make a box plot. We're just going to look over this. We had Q1, Q2, Q3, the three quartiles, right? And Q1 separates the bottom 25% from the top 75%, and Q2 is the median, and Q3 separates the bottom 75% from the top 25%. And the interquartile range, again, is Q3 minus Q1. And that section is, we sometimes call it the middle 50. So just a little review. Visually, another thing we had here, which we're going to dig into a little more, is this idea of percentiles, right? So Q1 was the 25th percentile, Q2 was the 50th percentile, and Q3 was the 75th percentile. Okay, so with percentiles, we're looking at something a little different than when we look at the z-score, right? With percentiles, we're in particular interested in where do we stand relative to everyone else. Like, relative to everyone else, where do we stand? So, like, where's our place in line relative to everyone else? And basically what we have is we can create this idea of percentiles where we measure what percent of people are less than you in the line. What percent of the entire line is less than you? So again, the kth percentile basically separates the bottom such and such percent, the bottom k percent, right, from the top 100 minus k percent. And again, this is to measure what percent of people are less than where you are, right? What percent are less than you? And by knowing what percent is less than you, you should also know what percent is greater than you, which thus gives you your place in line. So here's an example with percentiles. And the reason why this is all related to the median is because, again, the median is measuring where the middle place is, right? That's what the median is measuring. So here in this example, this is you right here. You are the fourth, right, from the tallest. So this is a group of 20 people, and you are here, fourth from the tallest. So when we want to find the percentile, we want to find what percent of people are shorter than you. Well, we can just see there are 20 people all together, and if we count it, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 people, and then you. So what percent of all of the people are going to be shorter than you? Well, these 16 people out of the 20 people altogether are shorter than you. So therefore, 16 over 20, right? That's how many people are shorter than you, which is going to equal 0.8. And as a percent, that is 80%. So what this is telling us that we are in the 80th percentile, or in other words, 80% of the people in the line are shorter than us. So let's keep going. We're going to get a formal way of finding the percentile. If we have the space in line, we're going to get a formal way of finding the percentile here. The first thing we want to do, similar to how we find the median, is we need to sort the data from smallest to largest. Second, we need to find what place in line the data point that we care about is, right? How many places, how many spots are less than the data point that we care about? And then we also need to know how many data points are there in total. And then we just divide. We divide the total number of data points that are less than the one we care about, or the amount of data points that are less than X, we divide that by the total number of data points. And then we multiply by 100 to get 8%. So if we follow these same steps here, step 1 would be put everyone in a line. So yeah, everyone's in line from shortest to tallest. Step 2 would be what's the person's place in line. That would be 16, right? That would be the place in line, right? So our place in line, I'm sorry, I put the 16 there, but the 16 is measuring how many people, right, are less than you. There's 16 people less than you. So that's our place in line. And then we need the total. Well, in total, there were 20 people. So we have that. And then we divide. Well, that's kind of like what we did over here. We divided how many people were less than us by how many people there were in total. We got 0.8. Then we multiply by 100. And multiplying by 100 is changing it to a percentage. So we move our decimal point over 2 spaces. And we get 80%. And so finding percentiles is very straightforward, very simple, very easy. Let's do another example. So let's say here we collect a bunch of, let's say we're measuring children's head sizes. How big are these babies' heads? So we collect a bunch of baby head sizes, and we get that one baby's head is 7 inches. Another baby's head is 6 inches. We get 6.5 inches. We get 9 inches. That baby has a big head. 8 inches, 7 inches. One baby's head is 5 inches, 5.5 inches. So let's just do this many, however many this is. I think this is 8. So step 1, we go back to step 1, sort them. So sort, we're gonna put a little check next to sort them. So to sort them, we need to put the smallest at the top and then work our way down. So the smallest one, that bottom one was supposed to say 5.5 inches. Let's put 5. So we'll start from the bottom. Which one's the smallest? I think 5 inches is the smallest. Then we have 5.5 inches. Then we have 6 inches. Then we have 6.5 inches. Then we have 7 inches. We have another 7 inches. We have 8 inches. And then we have 9 inches. So we did step 1, put them in order. Step 2, our place in line. So now here's the question. Which of these data points is it that we care about? Well, our child's head was 6.5 inches. Right? That was our child's head was 6.5 inches. And we wanted to know what percentile that put our child in. So for that 6.5 inches, we need to say, count how many data points are smaller than your data point. And I'm making this all up, obviously, as I go. So 6.5 inches here. How many data points are less than it? Well, we got 1, 2, and 3. So that gives us our top number is 3. And then next, we need to see count how many data points there are in total. Right, so check. How many are there in total? There are 1, 2, 3, 4, 5, 6, 7, 8. So we have 3 divided by 8. And then next is to divide them. The amount less than your value divided by the total number of data points. We get 3 divided by 8. Now we need to do this division. So let's do this really quickly. So we have 3 divided by 8, and we get 0.375. So we go back, we get 0.375. and multiplying that by 100, we get 37.5%. And we'll just go ahead and round up, which makes it about the 38th percentile. So it's very, very easy to find what percentile something is in. Like, this might actually be like the easiest thing you ever do. It's a little bit of counting and then some division. You count it, then you divide, and that is literally all you have to do. So, what I want you to do, I want you to pause the video here. I want you to pick another number in our list right here, and I want you to find its percentile. And do that 3 times. Right? Pick another number, find its percentile, then pick a different number, find its percentile, pick a different number, find its percentile. Right? And that'll just be some practice. Again, it's a very simple process. You count how many are less than the number you care about, how many are there in total, divide, multiply by 100. So going back here, what if we wanted to find the place in line that some percentile was? So instead of saying, well, what percentile is 6.5 inches, right? Instead, we could say which person in line fits the 75th percentile? Which person in line is the 25th percentile? Which person in line is the 32nd percentile? So instead of going the other way, we can go backwards and say, let's find the person who matches this percentile. So to do that, our steps are just a tiny bit more complicated, right? So let's look at the steps and look at an example simultaneously. So what we'll do, let's say we wanted to find, for this section here, let's say we wanted to find the, let's just do the 45th percentile. So we need to find the 45th percentile. That is, I just put 45th percent. I should have put 45th. Let's do it this way. I'll be a little lazy. 45th percentile. Step 1, right, is to order all of the values in the data set from smallest to largest. We did that. They're already in order. That's the green line here. Step 2 is to multiply k% by the total number of values in. This number is called the index. So we need to find what the index is. That's step 2, find the index. So multiply k%. And again, since we're finding the kth percentile, think about what percent we need to find. We need to find what is the 45th percentile. That's what we were looking at here. So the percent is this 45%. So it says multiply the k% or 45% in this example by the total number of values in. So we're going to do 45% times n. How many values are there? There are 8 values. Now we can't do an operation with a percentage like this. So we need to actually change it into a decimal. So that's what we'll do first. 45% as a decimal is 0.45, and we're going to multiply that by 8 to get our index. 0.45 times 8, and we get 3.6. Now we have 3.6. That's our index. That what we just found was our index. So now step 3, it kind of gives us some different options. So if the index obtained in step 2 is not a whole number, round it up. That's a key word. We always round up in this particular example. Round it up to the nearest whole number and go to step 4A. But if the index is a whole number, go to step 4B. So this was our index. Now the question is this a whole number or not? Well, 3.6 is not a whole number. Since it is not a whole number, what does it say do? Not a whole number. Round it up to the nearest whole number. So we're going to round it up. When we round it up, we'll get 4. And then it said, and go to step 4A. So 4A says count the values in your data set from left to right, or from smallest to largest, until you reach the number indicated in step 3. So we need to count until we get to 4. And then that number will be the kth percentile. Okay, that's easy enough. So you go, let's count. This is 1, 2, 3, 4. That's the kth percentile, 6.5%. So we got the 45th percentile is 4. It's 4 from the bottom. And the value of that percentile is 6.5 inches. Now you may be like, wait a second, I thought we said 6.5 inches was the 38th percentile. The problem is that these percentiles kind of span a range of values. They don't just each get their own individual value. Like, they're not enough numbers for each one to have its own value. We would actually need like 100 different values for each one to kind of have its own value in that way. So it's a range of values. So the 45th percentile also fits for that 6.5%. So let's do another one, but this time we'll do one that should get us a whole number. Let me think what will get us a whole number here. 1 second. Because I want to do it like with the other direction, in the other direction. Let's find the 75th percentile. Right, so for this other one, we'll find the 75th percentile. So for the 75th percentile, what was step 1? Step 1, order all the values. Well, we already ordered those values. Then we need to multiply k% by the total number of values to find the index. So the percent is 75 here, so we're going to multiply 0.75 times 8, right? So let's pull out our calculators. We get 0.75 times 8, and we get 6. Now we go back to our steps. And when we get to step 3, if the index is not a whole number, well, this is a whole number, so we need to go to the other part. If the index is a whole number, go to step 4B. So it was a whole number, so we need to go to 4B. 4B, this one, says count the values in your data set from left to right until you reach the number indicated by step 2, right? Until you reach the index, pretty much. And the kth percentile is the average of that and the corresponding value in your data set, or the value that directly between that value and the next value. I'm sorry, I'm kind of got tongue twisted a little bit. So we'll do it, and when we do the example, it should make a lot more sense and be easier to follow. So here we need to count up to 6. So we have 1, 2, 3, 4, 5, and 6. And the kth percentile is between the 6th one and the 7th one, because our index was 6. So it's the average. It's that space that's right in the middle between these two. That makes our kth percentile. So we have 7 and 8, and we need to average them. So we're going to do 7 plus 8 over 2, and we'll get 7.5 inches. And that is the 75th percentile in this case. And yeah, it's just a coincidence that it happened to be 7.5 and 75th percentile. There's no actual relationship there between the numbers. There's just a coincidence. So finding the percentiles is very straightforward. Either we're counting one way to find what in a person in line's percentile is, or we're going in the other direction, right, where we need to find what place in line is a certain percentile, right? So it just depends. And all of the steps are right here in the slides and very easy to find and go over, right? So when we go into class, we'll do some of these examples about finding the percentiles. Just as a review, so z-scores, which was what we did last week, tell us how far from the mean a data point is, right? From the mean. That's the important part. They're telling us about the mean. And z-scores tell us about the actual value of the data set, right? Or the data point in the data set, right? So it's telling us about the value. So it doesn't really care about the place in line. It more so just cares about what the actual value is. And z-scores are extremely important when we do inferential statistics, because there is a way to tie the z-scores to different probabilities, which basically serves as like the bridge between the z-score stuff and the median or percentile stuff. On the other hand, quartiles and percentiles tell us about relative standing, or basically where someone is in line, right? So that's what the quartiles and percentiles do. Whenever you're trying to do something with quartiles and percentiles, I want you to imagine standing in line with a bunch of people, counting how many people are shorter than you, and then figuring out what percent that is of the whole group. And percentiles are often used to compare real things in real life. So, for example, if you have children, you probably have taken them to the doctor at some point and gotten what percentile they are in, for their height or their weight or anything like that, right? And the doctor will basically base whatever recommendations they give to you on whatever percentiles they are in. Another example might be if you take a test. Sometimes tests will give you the result in terms of a percentile. Basically, it's a result that is relative to all the other student scores who took the test at the same time. That might be a test like the GRE, stuff like that, right? Where the score is relative to everyone else who takes the score. You get your percentile back. So with that, we are all done. That is all we have. So very, very short stuff with the percentiles and quartiles. The best thing for you to do is practice. So what you can do is you can take that list that I have earlier with the heights. Just go back to that part of the video, pause it, find a bunch of different percentiles, right? Pause it and say, well, what would be the 87th percentile? Just come up with a random number. Well, what would be the 95th percentile? And as a bonus question, when you come back, I want to hear which number, and think about it carefully, and do some little examples to see if it can help. I want to hear which number you think will be the 100th percentile, right? Which number is the 100th percentile? That's something I want you to think about. All right, everyone, have a good day.